Let's talk about real polynomial rings. The elements of a polynomial ring are all the polynomials we can write down over a particular set of variables with real coefficients. We could ask, what are some nice functions between polynomial rings? For example, what are nice functions from Rxy to Rt? Well, I haven't said what nice means, so let's make some decisions about that. We'll say a nice function f needs to map constants to themselves, and also needs to be a ring homomorphism. That is, it preserves all the ring operations, addition, subtraction, multiplication. Given those constraints, our function is completely determined by what it does to x and y. F of x is some polynomial in t, and so is f of y. Another way of looking at this is our function is a description of a parameterized curve in the plane. The polynomials in t that f assigns to x and y say how to compute the x and y coordinates as a function of time. And if instead we had asked about nice functions from Rxyz to Rt, we'd find that they correspond to parameterized curves in 3D space. So we've seen that maps from Rxy to Rt are curved in the plane, and maps from Rxyz to Rt give curves in 3D space. We can play around more with the number of variables on both sides and see what happens. Maps from Rxy to just R are mere points in the plane, because we can only assign constants to x and y. Maps from Rxyz to Rtu are polynomial surfaces in 3D space, because for each of x, y, and z we give a polynomial for how those coordinates vary with the two time coordinates t and u. If we write these facts in a more uniform way, it's easier to see what the pattern is. Nice algebraic maps from a ring with n variables to a ring with p variables correspond to geometric maps in the other direction, from p-dimensional space to n-dimensional space. So it's very tempting to say that Rxy is, in some sense, a two-dimensional space, and Rxyz is a three-dimensional space, and so on, except somehow backwards or upside down, because the maps between them get turned around. This is a taste of a really deep and interesting theme that's at the heart of algebraic geometry. The algebra and geometry are in some sense dual to one another. I hope to make a few more little videos exploring this. Stay tuned.